Hey, what's up everyone? Today we're going to be talking about the dot product and the cross product. Let's get started. Let's take two vectors. Is there any way to multiply these two vectors together? Well, the good news is there is. Two ways, as a matter of fact. The first way to multiply is the dot product. The dot product gives us a number. To find the dot product, we take two vectors, multiply each component with each other, and then find the sum of all those products. Note that a dot b equals b dot a because addition and multiplication are commutative. The dot product is pretty simple, so let's do an example together. Find the dot product of 1, 2, 3 and 3, 2, 1. To do this, we simply multiply each component with each other, so 1 times 3, 2 times 2, and 3 times 1, and then sum them all together. At the end, we get 10. An important dot product to remember is a dot b equals 0. This is true if and only if a and b are perpendicular to each other. Our second way to multiply two vectors is called the cross product. The cross product yields another vector. To cross two vectors, we use this equation. So this equation is pretty ugly and hard to remember, so let's do something a little bit easier. First, let's construct a 3 by 3 matrix. Make the first row the vector ijk, the second row a1, a2, a3, and the third row b1, b2, b3. Now let's find the determinant of this matrix. First we have positive I and multiply this by a2, b3 minus a3, b2. Then we subtract j and multiply the determinant a1, b3 minus b1, a3. And finally, we add k times a1, b2 minus a2, b1. And we get this vector. Make sure that you remember this subtraction sign. It is very important. Now that we have an easy way to remember the cross product, let's do an example together. Find the cross product of 1, 2, 3, 3, 2, 1. Our first step is to construct our matrix. The first row will be ijk, the second row will be 1, 2, 3, and the third row will be 3, 2, 1. Now let's find the determinant of this matrix. First we get I and multiply that by 2 times 1 minus 3 times 2. Then we subtract j and multiply that by 1 times 1 minus 3 times 3. And finally we add k and multiply that by 1 times 2 minus 3 times 2. And voila, we have our vector. Note that the vector that we get from the cross product is always perpendicular to both a and b. But you may be wondering, this way is perpendicular, but so is this way. So which vector is the cross product vector? Well, we determine the direction by the right-hand rule. First, point your hand towards the a vector, curl your fingers towards the b, and your thumb points towards the cross product. Note that if we did b cross a, we would point our fingers towards the b direction, curl our fingers towards the a, and our thumb would be pointing the opposite direction. Thus, a cross b does not equal b cross a, and in fact, a cross b equals negative b cross a. An important cross product to remember is a cross b equals the 0 vector. This is true if and only if a is parallel to b. Now let's go over some fun facts before we end this video. First, take a parallelogram. If you make the two sides into two vectors, you can find the area of this parallelogram simply by finding its dot product. Now let's take a three-dimensional parallelogram, also called the parallelepiped. Now make each side a vector. You can find the volume of this parallelepiped simply by calculating a dot b cross c. Now let's review. We can find the dot product by doing a1 b1 plus a2 b2 plus a3 b3. We can find the cross product by constructing this matrix and finding its determinant. A dot b equals 0 if and only if a is perpendicular to b, and a cross b equals the 0 vector if and only if a is parallel to b. We can find the area of a parallelogram by dotting 2 of its sides. And we can find the volume of a parallelepiped by doing A dot B cross C of its sides. Here is an example you can do on your own. For the answer, click here. And remember everyone, understanding the concepts is only half the battle. Make sure you do plenty of practice to really hone these skills and master the material. Thanks for watching.